3 seconds from now. You're
Good evening, night or morning, depending on your time zone, everybody. Thank you for joining this session. Throughout the presentation, I'll use QR codes to provide links, but don't worry if you can catch them all immediately, as the session will be recorded, and I can provide the links during QA. Today, I'm going to talk about interactive streaming, or in other words, how to perform cloud-powered magic with Genvid. So I'll teach you how to run your first mile. First, I'll present myself. Since November 2020, I'm Technical Evangelist at Genvid Technologies, where we enable users to reach out and interact with streams in any platform. There's a lot to go over, and I want to start by introducing you to our company. Jamb was founded 5 years ago by Square Enix, Ubisoft, and AMD veterans, and we are backed by several prestigious VCs. We have offices all over the world, with headquarters in New York, a development studio in Montreal, live ops team in LA, offices in Tokyo and Berlin, where I should be heading soon once the pandemic allows us to travel again. Now I'll start the proper presentation. We believe that people love when their participation matters. A neutral response has been a YouTube running gag since 2009, where people vote thumbs up or thumbs down, so it's always in perfect balance. I think that I'm going to move my head a little. Yeah, okay, I can, perfect. Reddit Plays had 1 million users placing a total of 16 million pixels to draw complex shapes, symbols, and images. Even people organized around in guilds in Reddit, in subreddits to fight over turf. It was a very fun experience. And Twitch Plays Pokemon holds the Guinness World Record for having the most participants on a single-player online video game with over 1 million players. And also, we believe that people love live events. In February 2019, Fortnite's Marshmallow Concert became the game's biggest event ever, with 10 million people in attendance. But it wasn't just the novelty. People are drawn to communal experiences. On April 24, 2020, Travis Scott had an in-game concert that had over 12 million concurrent viewers. And now the Ariana Grande concert reached over 60 million people. But we think that we can go a step further, and we believe that we can give people magical powers. Gmp Technologies exists to give developers the tools needed to hand people that power. Bringing interactivity to live streams, creating interactive live broadcasts for sports, reality television, or miles of literally any kind. So you can provide each person with the preferred level of insight, interaction, and entertainment. That is our single-minded purpose as a company. We want to bridge the gap between the players and the viewers. Just like in a stadium, I think that I'm going to hide my head here for a second. Just like in a stadium, people can participate by cheering and basically chanting with other people on the benches, and players can feel that presence. We feel that when people stream, the viewers are craving for that type of interaction. And the good thing is that with our technology, the audiences don't need to install any kind of software. They'll interact directly on Twitch, YouTube, or even your own platform. In simpler terms, if you think about it, a stream is a point of view. Basically, it's a complex system, right? Where you can present spectators with a player's perspective, and they could see all that information that is available to the player, but you'll obscure all the relevant tactical information, such as the position and status of other players in the field. A player's perspective is just a fragment of a very complex and dynamic system. What you want is to present that dynamic in a way that it's easy to understand. And that's the reason that when we can direct that perspective, that's how we show a soccer match instead of a player's first-person view, right? But then you could go even beyond that. The digital market megatrend is a progression of user obstacle removal from desktop to computers to mobile to the cloud. This is something that we experienced firsthand in the video games market, where mobile gaming and free-to-play expanded the player base from a few hundred million to billions by decreasing friction. We believe that the next progression is to allow people to choose their point of view and the level of involvement and interaction without the need to install a special client. At Genvid, we are already working with tier 1 events, platforms and leagues, with people paying to participate in an interactive stream. For example, in the CSGO majors with their event ticket, each participant had a bird's eye view of the action with a minimap, the power to individually switch cameras, and surface data as they pleased. They could click on a player and see their loadout, their kills, their position on the map. And when they cheered, people that were commenting the stream were able to see which player was being the most cheered on by the audience. So they could focus their commentary there. But that's just an informational layer, or tech can be used to create a cloud-first, full interactive experiences like Rival Peak. Rival Peak is an ambitious transmedia mile or massively interactive live event that involved 13 persistent interactive live streams broadcasting the activities of a dozen AI-driven contestants on a simulated reality TV show. It originally ran from December 2020 to March 2021, and it was available on Facebook as a Facebook instant game. Each contestant had their own Facebook page, and we had a weekly wrap-up show featuring Will Wheaton that summarized the previous week activity and the evolving storyline. It had interviews with the contestants, and it revealed additional plot points. That show alone reached over 100 million views, and people within the game consumed over 100 millions of content. That's around 200 years. And the show is currently in rerun mode, so you can experience it by yourselves. That's why I give you that QR code there. It's covered by my Windows bar. But if you look for Rival Peak on Facebook, you'll see it. And basically what I want to achieve here in this session is helping you to run your first mile locally, so you can create experiences like that. I hope that you will have an understanding of how an integration with the Jamb SDK enables in-stream live interaction at a massive scale. But I'll be using Unity. Do remember, though, that our technology works with Unreal, Unity, and C++. So you can interact even with proprietary engines. And I will give you a little high-level overview first, so you can have a clearer picture, and then I'll dive into the project. That being said, we define the types of interactions in 3 tiers. We have the first tier, that's informational. That's similar to what we do in the CSGO majors, where people are enabled to retrieve a wealth of additional information within the stream. Like I said, like a minimap, the player positions, or a leaderboard, or any other type of real-time statistics. This will provide you with enhanced viewability. It adds tension and drives narrative. When fighting games are very easy to spectate because you can see the health bar going down. The moment 37 of Evo, when Daigo blocked did the Daigo parry, when he blocked the Chun-Li's kick 37 times in a row with a 2-frame window between inputs. It wouldn't have been as impressive if it wasn't for the fact that he was down to 1 point of health. Basically, if he hadn't parried each and every single hit, he would have lost the match. But somehow he prevailed. Without the health bar, that information is hidden for the viewers. So you can do that and surface additional information from your games. The second tier is customizable. Here, just like fans choosing their seats for a sports event, or technology allows your audience to fine-tune the experience. They can select their team, and based on their team, display to them a specific camera angle or engage in a chat exclusive to that team. And viewers of every type of background and interest can directly provide feedback and basically tailor their experience. Of course, you can also use this to customize native advertisements and experiences for each viewer group. Like say, imagine this was a FIFA match, you could be selling t-shirts from one team or the other, depending on the team. And then this is like where we really shine, the influential layer. This is going beyond passive viewing and turning the viewers into active participants. You can allow fans to cheer for their favorite players, and you can let those players feel the audience rooting for them. You can empower the participants to influence AI characters' behavior or replace anything that's RNG in your game. You can decide with a vote from the audience. And you could even let them take complete control of a cloud-first experience. Players and viewers mutually benefit from the emerging content due to this increased interaction and engagement. Basically, you can turn every part of your game into UCG. Of course, this has different levels of game design and development cost required. Just having an informational overlay, it's very simple. You only have to expose key data from your game that's been tagged in engine, and then you have to create a web view overlay that consumes that data. The second tier, the customizable tier, where you have customized camera angles and such. I'm going to make my head smaller, I think. Yeah, that's better. Requires you to identify and enable key customizations. It's basically something that requires you to have a very good understanding of your audience. Let's say, if I keep going back to the soccer example, because in Latin America, we don't watch any other type of sports. But when you go to the stadium, you prefer to sit behind your team's goal. So that way you can like be encouraging your goalkeeper. But and then there's people that prefer to be on the side to have a bird's eye view of the field. And those are the types of things that you need to fully understand about your game before thinking about enabling those customizations. Then the third tier, the influential tier, is the hardest one. Because the hardest problems are not technical. The technical problems we already solved for you. It's the game design and the experience design questions. You have to balance the player and participant interactivity. You have to think of ways of making something fun for 10,000 people playing it at the same time. And you have to create the game code to enable that interactivity, right? So yeah, but basically this is where you get the most bang for your buck afterwards. The way this works is that we have, imagine the OTT service is something like Twitch or YouTube or Facebook or any place where you can stream video to. And on top of that, you have a web overlay, think a transparent canvas, where people can do input, like click there, and that input gets summarized and sent back as an array of input back to the Genvid services and then back to your game or server architecture. But from the side of the game, what we do is that we send video and data that's being timestamped and synchronized. So when people receive the video feed and the data, from their perspective, everything is in sync. We divide that tape of data in three, yes, the data streams we divide in 3 types. We have data streams. Data streams are meant to be used to convey information that is constant, like the health of a character. So whenever you ask in your web use code for that information, you'll get the latest updated state or game state from that data stream. Then we have annotations that are used for data that doesn't persist over time. Let's say someone does a pentakill in a shooter game, and you want to display an overlay on top of the web view. You will use an annotation to trigger that specific event in a specific point in time. And then we have notifications that are immediate. These are not synchronized. They are sent as fast as possible and consumed as fast as possible. This can be useful if you want to open or close a voting window, for example. And then the user sends back summarized events that are sent as fast as possible back to your game architecture. But also we have commands. These are meant to be used by a producer. Let's say you are in a fighting game tournament and one of the players runs out of batteries in their controller, and it's your fault. It's not the player's fault. So you want to restart the match. You can then restart the match from a browser window instead of like going to the stage and doing a clumsy pairing of controllers or something on top of the stage. If you want to visualize this, think of your game or your experience as a clock. Visualize you have this clock, this physical clock that's being broadcast. So you see this video and audio stream of the clock hands ticking. But you want to provide an overlay that shows the precise time. So that's what we will use a data stream for. This will explicitly state the time and will be in sync with the video. This concept is similar to what modern video containers allow, like those Matryoshka files that contain several audio channels and subtitles in different languages, but they are matched to the synchronized to the video. This is very similar, but live, real time, and delivered massively. And basically, what you can do with this is that you can specify an arbitrary number of supplemental data streams. So if you think about it, like a live stream is a 3D object because you have a video, audio, and time, and you could add infinite amount of, or almost infinite amount of additional layers of interactivity or information. This data stream is identified by an arbitrary UTF-8 string called the stream ID, and each stream is filled with a series of timestamp data chunks, and that's how you associate every data element to a specific time, both within the stream and across other streams. But then, what if you wanted to send an event every time that a minute is reached? That's what you use an annotation for. For states that don't last over time, synchronized annotations can be sent to the participants. For example, delivering a tally of points that have been just scored, or like I said before, triggering a pop-up informing that a critical hit has been landed. Following our plug example, every time a minute elapses, you can send that data chunk in sync with the video. In this case, we do have a limit. We have a limit of 256 annotations per stream, per frame. Any attempt to add annotations beyond this limit will result in those annotations being dropped. But I can't think of an example of what could use 256 annotations. Please break it for us once you start doing your your experience. And then, of course, why will be synchronization important, you may ask? Imagine that you are in different time zones. You are in Germany, and in Santiago, Chile. It's 5:30 p.m. over there. It's 11:30 over here. But besides the time difference, we have a ping difference between each viewer. Some of you may be watching this video with up to 10 seconds of delay because of CDNs and other intermediate layers. So what we allow by having each data stream synchronized is that relative to your own perspective, everything is happening in sync with you. If it wasn't synchronized, you will get, for example, the annotation that the minute had elapsed out of sync with what you're watching. It's like when you are watching I'll go back again to the soccer example. When you're watching a soccer match over open air TV or cable, and there's someone watching it over satellite in the house next door, the people watching over satellite will hear you scream "goal" right before it happens for them. It's very jarring because they are watching it with delay. Then notifications are sent immediately. Like I said, if you want to open or close a voting window, as you can see in the example of the middle, that's the viewer that has the most ping, but they get the notification before. They get the notification before the annotations and the data stream and the video reach that point. That's because it's not processed. It's just like sent as is, and that ensures that we arrive faster. Of course, you can't break the laws of physics, so it can go faster than light, but it will arrive sooner, and it will display as soon as it arrives. So that's if we go back to the high-level architecture, that's how we send the audio, the video, and game data. Like I said, the game data can be divided in three data streams, annotations that are synchronized, data streams for states that last over time, annotations for states that don't last over time, that just happen once, and notifications for stuff that you need to let people know immediately. I don't know, that your server is going into maintenance, for example. You want to just notify people. You don't need it to be synchronized. It's just that information that you want to deliver to all your thousands of players. But now what I want to do is to focus on the events. Imagine that you have this server that is streaming, this GPU instance that is streaming, and you have 50,000 concurrent users like we had in Rival Peak, and all of them are sending input back to the game. That, from the perspective of your server, that will be a denial of service attack. So that's why all the events that we receive from the web overlay, we summarize. And how do we summarize? We use a Mapreduce algorithm. This is not exactly like the Mapreduce algorithm from Google, but it's different. Where we basically give each type of input that we allow an ID. We tell them where is it coming from. We have a where clause that allows you to match each type of input. And then we set it as a key value pair. And then when it's reduced, it will be reduced in a period of time that is defined in milliseconds. So basically, you'll be saying, hey, I want to receive all the input from all the players every 250 milliseconds. And then what you'll receive is an array of key value pairs that contains all the inputs. And you can have an operation performed on them. You can count the inputs. For example, if you're counting votes and you want to display all the options, or maybe what you want is to see how many people clicked on something in particular. So there you can sum those inputs. Or you want to do an auction, and then you can pick the maximum value. Let's say every person on the stream auction for something, and you can do, instead of sum, you do max, and you get the maximum value. And then maybe you want to do something for the people that give you the minimum value, and so forth. Then there are the commands. These are, well, again, putting my head on top of the graphic. Then there are the commands. Commands are not to be used by regular users because commands don't go through this Mapreduce algorithm. And like I said, these are basically meant to have a higher level access to your game. So you have to hide those behind a password or some sort of security measure, or not have them at all. Because if all the users were able to send commands to your server, then you will be facing a denial of service flag. Okay, I hope that most of you did watch the installation video that we sent with the newsletter. If not, I'm going to go over it like very quickly on how to install the Genvid SDK, and then I'll drop into Unity to show you how it works. So how we set up this local developer environment. First, you need to download our SDK and install it, as you can imagine. And then you have to run the installer and choose the option to install the complete SDK. The installer will check for dependencies to provide with a full suite of tools to create, deploy, and stream your projects. If any of those dependencies is present in your environment, it is safe to skip them as long as some conditions are met. For example, Python, it has to be a 3.8 point something version. We are not compatible with 3.9, for example. And then, if you don't have them, just proceed with the standard installation for each one. Once that is done, you have to install our suite of tools. We have a set of Python scripts that will help you basically run everything, set up Bastion servers locally, or deploy them to the cloud, or build your samples, copy all the SDK components to your project, etc. If you do have an advanced Python environment, you need to be careful though, because after finishing, the script checks if the toolbox was installed correctly, and if it's included in your path. And if it isn't included, the script will prompt you to prepend the tool's location to your path. But let's say you are doing stuff with neural networks and PTorch and I don't know, all those Python frameworks, and you have this very delicate system, then I would suggest you to look into the advanced Python environment documentation. This is beyond the scope of what we do, but you need to be mindful of that, or we don't want to damage your environment. After that, you will need to log off your Windows session, and then you have the SDK installed. Basically, that's all you need to do in order to install the SDK. Now I'll go over our sample project that we have in the Unity Asset Store. I'll show you how to set up, build, and run the Genvid tank sample, and I'll give you an overview of its features. And I'll also explain in detail the Genvid prefabs that we provide, so you can easily set it up for your project. This looks a little like this. Basically, you have a Unity project running, and then locally in your computer, and then it is streaming locally to your computer, and you can access those websites and interact as if you were watching it on a stream. So first, what you need to do is to create a new 3D project. I'm going to name it Genvid Thanks Sample inside the Genvid folder. I'm doing this because we told you to use an environment variable to point towards the binary of the game. So if you use a different path from what I'm going to show, it won't be able to find it. So in that case, you will need to note where did you place your binary file. And also keep in mind that this sample will work flawlessly for Unity 2018, 18.4.f, all the versions from the LTS release. If you try to use it in a newer Unity version, you have to be careful because it uses the older input system for the players. So if you try to import it, let's say in Unity 2020, it will break and you will think that it's our fault. It's not fault. I'm developing samples right now that are more version independent, but at the moment, this is what we have. So once you have your project created, you have to go to the asset store and import the I'm going to show it again, the Genvid Thanks sample asset. And once you do, you have to go to the Genvid Thanks folder, and then you'll see a zip file. In that zip file, we have all the configuration files needed for the local server configuration and for the stream configuration and all the Genvid services configuration files. So you have to right-click it, show it in Explorer. That way, it will show it in the location in your project. There, if you don't want to have problems with source control, please delete the Genvid services.zip.meta, the meta file, and then move the Genvid services. In this case, I want to move it to the root of the project folder. It may be smarter to have it outside completely of the Unity project, but for simplicity, I'll just keep it there. And then we'll extract the contents there. Once you do, your project folder should look like this, and then it's safe to delete the Genvid services zip because we have them in that folder. And now I want to talk a little about the configuration files. So first, you have to enter the config folder. And inside that, there's a file called game.hcl, and now I'm going to show you like my real window. Boom. Here I'm just going to open it. I'm going to close all these other things that I have here. One second. Yes, and I opened it in the text editor of your choice. I partial for Notepad++. Other people may have other preferences, because I can do this, so I can zoom. And in your case, it will say Genvid Thanks Project. That's the Unity product name. You have to replace that for Genvid Thanks Sample. And here, you can see that we are using an environment variable to point towards the sample, because that way you can like distribute it to other people if you're working in a team. Otherwise, it will be complicated because you will have, I don't know, c/windows/users/documents, and then it will break. So it needs to be relative. This is where you will point to it. Then we do have other configuration files. We have other configuration files. Sorry, I'm going to close Slack. I just got distracted by my own team. Like this one we are not really using, but if we go to the web HCL one, you can see that here what we do is that we are showing where are we pointing with the web server that we're going to run locally, and then this is the name of this web that we're serving. I'm going to do something. I'm going to replace here where it says Genvid Thanks Demo. I'm going to add 2, so you can see something later in the Unity interface. And then we have another configuration file, that's the stream, where you can have your web gateway secret and Disco secret. I don't know if you're seeing it properly. I'm going to see myself here for a second. Yes. What the other thing that we're doing is that in order to have a local experience that's closer to the real thing, we can add some input delay because there's no way around it. If people are kilometers away from your stream, and if your stream went through thousands of CDNs, different CDNs, it will have a delay. So here you can set an extra delay for the stream. And then in other configuration, we can set an extra delay for the data, and the input, and so on and so forth. Okay, I'm talking a little like CSEC. Sorry. Okay, so I'm going to close this. Like I said, first make sure to point towards the proper binary file, and I'm going to minimize this. I'm going to minimize my real window. I'll continue with my fake window. Then you have to navigate to the web folder within Genvid services. So we have Genvid services, and you go to the web folder, and then we have here we have this Python script called build.py. If you open a PowerShell instance here, if you go to the top left corner, go to File, you can open up a Windows PowerShell, like right there. And as you can see, it's exactly on the same location. Here, we need to first, because I have a lot more files that maybe you're not seeing. That's because I already built the web page. So if you do, going back to my fake image because it has a larger font. If you do p build all, it will first prepare the project, importing all the files that are needed, and then it will build the TypeScript files and the web page views, etc. Then afterwards, you can do p build p. Instead of all, you will pass the build parameter because you already prepared the project, so you're not importing anything new. You're just like rebuilding your TypeScript, so you can go faster. And then we have to go up one level, and we also need to call this environment variable. In this case, it's C Genvid text sample. That's the root of our project. And then we'll go back to the Genvid services folder. In that folder, I mean, this doesn't have to be in a specific particular place. This is basically installing the Bastion. Bastion is like the service that is the service that orchestrates all the servers that will be running locally on your computer, There are Bastion templates that you can use when you upload to, let's say, Amazon Web Services or Azure. Because, of course, what you want to have is like a GPU instance. And, for example, to consume the events, you want to have several different Leaf servers that are consuming all the input instead of doing all the work in one instance. So that's why we use a Bastion. In this case, we'll install a Bastion with an ID of local Bastion, and we are going to load a blank configuration. This name is important because then we can point to that Bastion with our services. And then once that is done, we run Genvid SDK setup to set up all the Genvid services using those blank configuration files. It's not necessary when the first time you run a Genvid project, but it's a good practice to clean any old configurations, just in case, because your project may have let's say, two streams, and you had configurations for those two streams. And then you will start a project that only has one stream, and you have one less configuration file, and basically it wouldn't overwrite the previous one. So that's why I usually just like, as a tradition, I start by cleaning the configuration and then loading a blank configuration. Basically, this is the base configuration of the SDK, and then on top of that, I'll start loading my stuff, right? So this doesn't matter. You can set the environment variable before or after, but not beyond this point, not before you load the specific project configurations. And as long as you don't close the PowerShell window, you won't lose this environment variable. So once we've done that, we'll run a Python script that's called py genvid project.py load, and this will load all the configuration files that we have on that project. I'm going to show you here. So basically, what we do is that we go and run this genvid project.py file. I don't know if I'm seeing myself. Yes, I'm seeing myself. And then what this py project does is that it looks for this HCL file called projectconfig.hcl, and that file is here. And what it does is that it shows which configuration files are needed. So we have the streams, that's the one we had right here. We had the events that I didn't open. The events are the JSON Mapreduce schema. So we'll use that because we want to do things with the sample. The web configuration, because these are the links, the web page that we'll be serving, that we want to show. And the game one, that's the one that points to the binary and tells you where to do the logs for the binary and all that things. So what the Genvid project.py does is that it just like loads this configuration file, and that configuration file points to all the others. So if we go to the configuration of our project, you can see that I have an extra one here that's called sample. We don't really need this one. If you were like to delete it or comment it, it won't happen anything. Nothing will happen. Okay, so once we've done that, you will have a project that looks. Oh, I have to open it. Oh. Okay, you will have a project that looks pretty much like this. I was cheating. I had it running before. I want to stop it. Stop the word. Oh. Okay, so this is the scene. If you go to Genvid Tanks content, if you go to assets, you'll see that we have scenes, we have Genvid tanks content, the original content from the original Unity sample, and within that we have Genvid tank contents modified and tank content. In tank content modified is where all the files from the Genvid things reside. So we have this Genvid tanks scene. If you open that, you will click it, you will see this distribution of things. Give me 1 second. Before I dive like too deep into this, I want to show you how it runs, so you can see. Because I'm doing like all this explanation, but I want to show you something cool. Give me 1 second. I'm going to start the services to Genvid, and because we have this Genvid tab here that you can open from the window Genvid menu. So first, I start the services. It takes a little while. Then I'll start the web that we'll stream to. And if I were to start this job, it will load the actual binary that is compiled. But I want to show you that it's possible to just press play from the Unity editor and stream from there. So I'll do that. Okay, that was already muted, so I'm not going to go dev. That's awesome. Okay, so with the sample running, you can go here and see, open the Genvid tanks demo. And here we are. This is fun because you can like toggle a minimap, and then you can see the position of the players. So I'm going to be here, and I'm going to move like my tank. And with a little delay, you will see that it's happening here, and basically the position of the tank also updated on the minimap. Then you can also, like I said, you want to cheer for someone, and you want them to feel that they're being cheered for. You can start pressing the cheers, and that way you send an event back to the game, and you have these floating hearts on top of the tank. And if you see, they are actually here. It's not on the overlay. It got sent back to the game. Other things that you get to vote for the loot drops with the options. And I'm going to move my tank and collect that one. Not that one. That's not the one that I wanted for. Boom. And that way I get my upgrade, right? And I can vote for shield. Yeah, it's going to take a while. And the other thing that is fun that you can do, so I'm going to move this downwards so I can play while I stream, is that, like I said, if you, I'm not that good at this. If you kill someone, you will get the overlay. And of course, the round will be restarted. And the vote that we did for the shield, I think that's the shield that I voted for. Okay, I want to show you the types of upgrades that we have in the game, because now I want to show you the administrative interface. Also, you can like click on someone and get all the data from that player, and this will track the player as it moves. This is just a div that is being drawn on top of the video, just like the banner ad there. But what I want to show you now is the administrative panel. It will ask me for a password that by default is lower caps admin, lower caps admin. Sign in. Yes, I don't want to save it. And there seems to be an error. Here. Now I'm going deaf. But here you can restore the match. And you can, for example, give to the second player the attack buff, the movement buff, the chill buff, the health buff, all the buffs. I want to close this. And if I reload, oh, it died. I think that I messed up a little too much with it. Okay, here. I don't know what was the problem there. I think that the admin panel didn't play nice with it running from the Genvid, from the Unity editor. I'm going to try again. Sorry, I want to try again the admin panel. Because what I wanted to show was there. That's what I wanted to show. Basically, you can even have a producer send stuff to someone and affect more directly the stream, right? Give me 1 second. Here on the top right, we see information about the latency. Like I said, we had set the latency to 2 seconds. That's why it's 2,000 milliseconds approximately. And then this is just like the bare minimum that you can do with a game. Of course, what we did with Rival Peak was a lot more involved. But I want to go over particularly on how we did the minimap. So it's easy to understand for you how we did that and how you can do it on your own on your own project. So first I'm going to here. So here I'm going to stop the web page. I'm going to stop the services, and I'm going to stop the game. Okay. Perfect. So how does this all work? First, in any project that you are trying to develop with Genvid, you have to import a prefab. I mean, you have to import the SDK. I want to see if I can zoom here this thing, so it's easier to see. Well, I'm distorting it. That wasn't what I did. I want to do it the other way around. Yes, there. So if you can see here, the Genvid Session Manager is the object that contains all these all the game objects that are needed for a Genvid project. This can be gotten from here, from the SDK asset that you download. And basically, it's a set of prefabs. You just like drop them into your scene and start configuring them. The Genvid Session Manager must be persistent throughout the game. So you have to make sure that it exists when you change scenes in your game. So that way the connection to Genvid services is not lost. And inside that Genvid Session Manager, you have the actual Genvid session. And the Genvid session contains the video, audio, data stream, events, and command game objects. So in the hierarchy, it looks like this. You have the commands, streams, audio, video, events, right? So I'll go first over the video because it's the simplest concept to understand. Here, no, I got confused because I was moving the the actual screen. So if you go to the video prefab inside the Genvid session, you can see that we have a stream name, That's how we can identify a stream from the Genvid services. Then we have the frame rate that should, of course, match the frame rate of your game, because it would make any sense to stream faster than that. Or you can go lower because, for example, the game is running at 60, but then most streaming services consume video at 30 FPS and not 60. And then we have two types of capture. We have the automatic capture and the texture capture. The automatic capture will basically capture all the video that's been composed by the binary. But if you choose a capture type of texture, you can, for example, hide the HUD of your game and just show like the gameplay, and you can then redraw the HUD on the web view. That way, you can do some fun stuff. For example, I'm going to show you something old that I did. This is something that I did, I think, a year or 2 years ago. This pandemic thing makes me lose track of time. But here, I had a fighting game where all the HUD was being drawn on the web view, and you could turn on and off the input.
Sorry to interrupt you. You are showing a bad resolution. On
sorry,
the
sorry. I was. Excuse me, people. I was showing something from the editor, and then I got carried away. But here it is. Okay. So yeah, no, that makes the explanation makes sense. Thank you very much, support, for letting me know that I was streaming whatever. So in this game, this is in Unreal, but basically I was still capturing a texture, so it had no HUD, no in-game HUD, and all the HUD was being drawn on the web view side from the people that were watching on Twitch. Well, yeah, and what you could do then is, for example, turn on and off the hitboxes of the characters, and you could also turn on and off the inputs that all the people were doing at that event, because this was at Evo. We had people playing on some PS4s, and that was streaming to a server, and then we had computers at Evo where people could like turn on off the HUD and the hitboxes. It was really cool. So you can do stuff like that, like I said, with a capture type of texture. So that's why you would want to do that instead of just capturing all the video. Then the audio. And by the way, if you set the capture type to texture, you can actually change the video source dynamically. So you can have multiple cameras and change them throughout the game experience. And that way you have better control of what you're showing instead of having just everything being shown. Then we have the audio. Oh, misclick the audio. And the audio has also a stream name. I'm going to make it larger. Yeah, so you have the stream name, so you can maybe have more than one source of audio. You can change that. Then the audio format. Basically, you have a floating point 32-bit depth audio or 16-bit signed audio. That's it has to do with the audio quality. But then it all depends on the on what the platform that you're streaming to allows you to use. And then the important thing is the audio mode. You can have like no audio at all if you choose none. Then you can have a WhatsApp. This is the Windows Audio something API. This will capture all the audio from the computer or the server where this is running into. So if you have like a Slack notification like I did before, everyone will hear it and not just. So it's better to use the Unity audio source, and this will use the audio listener from the scene as the source for the audio. And of course, you can change the audio listener programmatically from within Unity, and that will make it easier to handle, in my opinion. And then now I want to show you the commands. Commands are the easiest to explain because it's just something that you receive, and it's basically you define the amount of commands that you can receive. And in the case of the tank sample, it's two different commands. We have the restart match command and the power up tank command. So here you define its ID. So it has to match from what's being sent from the web view. Otherwise, it won't accept it. You can still be a denial of service attack. So you have to be careful in your security layer. Don't just rely on the configuration on the Unity game of it, please. And the power up one. And basically, once that command is received, is processed by a C# script. In this case, this command object is talking to Genvid tanks commands.cs that is found in the Genvid tank contents modified. So go to scripts. I'm going to open this. Give me 1 second. I'm opening Visual Studio. And I'm going to, in the meantime, rescale my window to a more appropriate size. So, yeah, here it is. Basically, when you receive from the web view the onRestart command, if it matches the ID, the unique ID that we defined, it will stop the match, then restart the match, then start the match. In this case, it's a very simple interface. And then in the command power up, what we do is that we first get the unique ID of the tank that we want to power up, right? And then we get another string that is the buff ID. That's the type of ID, and then we decide what code to execute on the Jamb side based on that ID. This on the web view side is just a TypeScript file. I'm going to show you. I'm going to rescale my window here. So in the web view side, go to Genvid Services, web, right, public, and then we have this admin unity.ts and this admin HTML. If we look at it from the perspective of a viewer, well, never mind. I did something wrong. I double-clicked the thing instead of opening it. It's basically a web page, right? So we have this web page, and in this web page, we have these buttons that allows us to go to the. Oh, it's smaller, a little smaller. and a little more here. Okay, perfect. We have these buttons that are right on the top of the view, right? But then we have a button. We have here. We have this admin space, this div, and in this admin space we have a table that gets populated via TypeScript file. But you can do it in any way you want. If you go to admin unity.ts, when this gets built, basically what we do is that we look for the we look for the game data, and like I said, here we just inject these buttons that have the type of buff, etc. But in the case of the restart match button, is we just add this button and we add an event listener to it. And when it gets clicked, I want to move my head because my head is and when it gets clicked, then it triggers an event, and this event, that's called restored match, will send a promise back to the server, and it will run the code on the client side, on the Unity side of things. So if you think about it, the structure of the things that you want to do follows a very simple architecture that's very easy to grasp. I'm going to open a thing here so you can see. If you think about it, I'm going to zoom out again. Yeah, it's in a terrible resolution. No, here it is. So you have the game object in Unity. Then that game object has an ID. That game object interfaces with some C# code. That's very simple and friendly. Then you have this TypeScript file or JavaScript file where you do something with the information when it's received, and then you interface with a web page. It's not that much harder. In the case of if it was done in Unreal, you would use blueprints instead of C# code, or you could use the C++ interface, but it won't be that much different. In the case, I'm going to open my speaker notes so I can move the thing from the other screen. I'm going to go to the first slide so I can explain properly. So the command was very simple, right? Because it's only passing one single input from the web view back to the game. But how would you do, for example, the minimap? The minimap is more complicated, right? It has more layers of information. It has these tanks that have an orientation. You can see the bullets when to shoot. You get the position of the loot drops, and it can be hidden and shown, right? So how does this work? First, you will go to the streams in the tank sample, and you will have one of the streams will be called frame data. And again, here you see this frame rate parameter. In this case, it's set to 30. This means that this data will be refreshed in sync with the video frame rate. If it had a frame rate of 15, then what will happen is that you will get your data updated every other frame for some types of data, That's good. For others, not. If you want to track the position of the tanks in the minimap, it is ideal to have it in sync. But let's say you want to update the amount of victories that someone has, you could update it once per second. So you could set a frame rate of 1, and that will only update it once per second because you don't need it to be like completely in real time. Then this game data is being submitted, but some C# code in the Genvid Tanks game data stream that is found on the Genvid Tank context modified folder here, like you see, I assume there. And what does this method do? It takes this stream ID, right? And if everything is working, if the session manager is initialized and it's enabled, and this game object called high refresh tank data exists, if this variable exists, and it's not empty, it will create this game data object, and it's going to be serialized and sent as a JSON stream to the game. Basically, there. Now, the content of that data is some variables from the game that we just serialized. In particular, the ones that we need for the minimap are the data about the tanks, their position orientation, for example. Then the data about the loot position, the position of the bullets, and the position of the explosions. Like I said before, you just have to interface with a web page that, of course, was built during the unity.py.build process. So if you go to the index.html file, that's very similar to the admin one. You just have to look for this div called map overlay, class map container that has a 2D canvas inside. And we'll draw to that 2D canvas from TypeScript. We'll first select that div, and then we'll get the canvas from that div. And we do this during the onVideoPlayerReady event. That means that once the, sorry, I have my head in the middle. Almost. So once the video starts streaming, we then access these elements. And once we have that, during that same phase, we'll preload some images, basically a background image of the map, a red and a blue tank, right? The shell, the impact for the explosion, and the round thing that represents the loots in the minimap. And then how do we hide and show the minimap? It's just a simple CSS thing. We have a button that we saw in the example that's called toggle map, and when you click it, it will call this function that changes the CSS property from block to none, and if it's set to none, it won't draw it. But of course, before we are able to display that minimap, we have to pass some information to it, right? Like the positions and everything. And we want to do that in sync with the video. So on draw, we will call a function that updates on each new frame. And that way, we'll update the data. And what we do is that we iterate over those JSON files that we receive from the game, In this case, we are looking at the game data one. And we are parsing that data. And then what we do with that is that we pass it to this function on new frame. And this is the data that matters to us right now. That's the, I want to make my head smaller. That would be a solution. Yes. Okay. What we do is that we get all the data from the tanks. That includes the health and all other information that we are not going to use in the minimap. But basically it includes all that. Like I said, the explosion matrices, the loot matrices, and the shell matrices. And then this is very simple. I mean, if you're a game developer, you've probably done this before to make work anything in your game. And then during the update, we do is that we iterate over that data. We do a for loop in this case. In the case of the tank data, we get their health because we don't render the tanks. It won't make sense. We set a size, right? And we center the position. We define a center of that tank with some basic arithmetic. Then we get this tank matrix that is, of course, in 3D space. So what we have to do is to just do some math to translate that position in the world space of the Genvid, of the Unity client to 2D space in the canvas. So basically that's what we're doing here. And then we have to do that for the shells, for the loot drops, for the explosions. And that closes the interaction loop. I distorted myself again. Okay. So this is pretty much all that there is to the integration. It may seem daunting to do something like rival pick, but I'm trying to find my thing here. But there's not that much to it, like I said. What we do is that we provide the Lego pieces for you. And once you have those Lego pieces, you can do whatever. You can have a game where people can place things into the game. You can have people interact directly with the players. You can have, I don't know, a racing game. Do you remember this PS3 game, I think, called Split Second, where you were racing and you could make like the bridges explode if you went through them first? Well, here you will have a racing game where people make the bridge explode and affect all the people in the race, and so on and so forth. So I want to leave some time open for questions. So please just let me know.
Thanks for the amazing talk. It's been very interesting, and we will go on with questions now, which will be read out loudly by Alejo.
Yeah.
And therefore, I would hand this task to Alejo, who will now. Is he gone?
Okay.
Oh no, there is.
I'm
Okay.
here. I'm here.
Nice, excellent.
Okay.
Who will now be there to do the Q&A for you guys. Have fun.
Yeah. Shall we start? Are we ready? Okay. First we have, can everyone hear me correctly? I think so. Do you hear me?
Yes, I do hear you, sorry.
Okay. Well, first we have Miss Lisa Link, and the questions she's asking is the following. How do you make sure the viewer won't get overwhelmed by the amount of interactions and will still be able to focus on the event being streamed?
Well, that's a game design question or experience design question, because basically what you do is that you decide what you show. I think it's personal preference. I show this hyperactive thing that I like, but you could have something like very calm and very like wholesome, like I don't know, a singer, and you see the lyrics of the song played next to the people singing. But yes, I just show you a very like intense example. But like I said, it depends on what you want to design.
Okay, very good, thank you. And we're going to the following. Um, from Timothy Engel, I believe it's said. Sorry if I misspelled it. One question is, what decides the amount of games simulation instances that need to be running? Amount of viewer, amount of cameras, POV, etc.
Okay, perfect. The amount of servers, like simulation instances, I'm going to refer to them as GPU instances, are limited by the amount of concurrent streams that you want to have, because you could have one GPU instance that streams to 50,000 people, but then if you want to have in parallel a different camera angle, you will need to have a different instance running. This doesn't scale properly. The problem with, for example, with pixel streaming in general, is that it gets really expensive really fast, right? So if you had one stream per player, that would be unfeasible, or very expensive, or you need to have very deep pockets, like Google type of pockets. But with our tech, you can have like one instance streaming to 50,000 people, and then you just have live servers that reduce and map the input back to that instance. So yes, in the case of Rival Peak, we had 13, sorry, 13, 1, 3, GPU instances, because we had one per character. One camera was following each character, and we had a home stream. And with that, we had 50,000 concurrent players, no problem.
Okay, thank you. And the next one is from Timothy too, and it says, "What is the difference between the two SDKs, I believe it said, offered on the Unity Asset Store and the single zip SDK from the Genvid website?" Sorry, I don't know how to spell SDK properly.
If
If
I
you want,
think
you
that
can look
you
at the
like.
question.
Sorry, what did
Yeah.
he?
Basically, the
That
difference between
well,
the two SDK that's offered.
okay. What we offer in the Unity Asset Store are the prefabs to interface with the SDK that you install separately. You install the SDK separately, and then to talk to the SDK, you use the Jamb, the prefabs that we have on the Unity Asset Store. And also we have an editor package there that gives you that window that I showed during the presentation, like this Genvid window. It's like optional. You don't need it. You can do everything from the command line, but we thought it would be nice to not do everything from the command line when you're doing things locally. That's the main difference.
Okay, perfect. And the last one from Timothy. Is it possible to have users event affect with which commands are unlocked for the producer of use? To use, sorry. And share a bit.
Is
What do
it
you want to
possible to have user events affect which
affect
commands
which
are
command?
unlocked for the? Yes. I will suggest you, if you want to do something crazy like that, and I like where your mind is going towards, I will suggest you to use a player data service in parallel, like PlayFab, for example. So because then you can like validate all the interactions without the latency of going back all the way back to the game server. You can, because if you are having a live experience with lots of people, you want to have a identity, inventory, right, and attribution. And those three things can be done with a player data service. And when you have that, you can actually have game rules that are enforced by the player data service that could, for example, unlock stuff for a producer. That's a very weird and innovative thing. Yeah, I would like to see what you're going to do with that.
Okay, thank you. And the next one is from Nicolas Burgos. Is there any technique to make the synchronization with the game and the player accurate?
In what sense? Like, what we do is that we solve the synchronization from the perspective of the participant, because what you're seeing, like right now, you're seeing a delayed video of me talking, right? And if I had a data stream that was running on the, I'm going to open the presentation, and I think it will be easier to explain. Of course, I lost it. The synchronization is relative to the participant because you are far away from me, right? But then there's no way your information can travel back in time and go back to the player. So it will always be delayed there. So what you do to allow that interaction to happen is that you create windows of input. Let's say for the next 15 seconds, you will be accepting input for something in particular. And that way, even people that are like on Wi-Fi on the airport will be able to interact with the thing. But yeah, it won't ever be like real time because, like I said, it's a physics problem, not a technology problem. If you want to do it the other way around.
That's the other question that Nicolas asked. Is there any way to implement it on Unreal Engine 4?
Yes, of course. Sorry, like I said, this sample I shown on Unity because like the compile times and all the things are easier on Unity. Because you will have me like here, like making one change and then waiting 45 minutes for me to show you something. Doing it from a laptop it would be ideal. But yes, it can be done in Unreal Engine 4. The fighting game example that I showed you, that was done in Unreal Engine 4. And it was running on a PlayStation. So yes, it can be done. And it can be done in your own proprietary engine with C++. We have a team working on a Godot engine game using that path. We don't support it officially, but they decided to go ahead.
Okay, thanks. Then the next question is from Miss Lena. She's asking about a part where there was your add here quote, and she's asking if this means that you can add custom ads into a game, and if it's possible, how does it work?
In this case, I had a banner image. It wasn't like the most prettiest thing ever, but in the tank sample, you have this like in the scene. I'm going to move my camera.
Okay.
I'm the worst artist. Sorry, but yeah, there in the thing that I'm not focusing properly. There, I had forgotten the key. And on the other side, there's like.
Christ, you can turn around by using Alt
right.
and left click.
Yeah.
Okay, fantastic. Thank you. Yeah, as you can see, I'm not an artist. I studied fine arts, but for some reason, I do this sort of thing. So what we did for that is that we got the projection matrix from the camera, and then we did some 3D math to display literally this image that's here that says your ad here. And if say you wanted to have customized ads for your game, you will need to have some way of updating that image, and just tag something in your game and use it. The good thing about doing it like this way instead of doing it in game is that you can have it customized by the geolocation of people around the world, or you can customize it let's say, like I said, if you're watching something like FIFA, and someone is watching the Arsenal and the other is looking at Paris Saint-Germain, you could have a Paris Saint-Germain ads for someone and Arsenal ads for someone else.
Okay, perfect. Then, and the other question from Lina, and can you make games where you put ads of other people?
Sorry, I
believe
completely lost the
Echo
signals.
has some sound issue right now.
Yeah, I completely lost him.
Oh, now he's back. But we can't hear you. Now we can. Yes. Excellent.
Okay. Can you make games where you put ads of other people into an environment like this and then gain money if players react to those ads?
Yes, but that's a business development question. If you want to do it on the cheap, you could have like Amazon affiliate links, and you could have like I don't know, like imagine a stream where you're like painting, like I want to do an ad for myself, and you're painting like figurines, and then you could like tag it with the brushes that you use and the paints that you use, and have the affiliate link there. That's something that could work, of course. I wouldn't be as disruptive as an ad.
Okay.
Yes, but it can be done. It's just a question of business development,
Okay.
not technical.
I'm
happy to answer. I'm happy to answer like business ideas because like the space is wide open right now.
Okay. Well, now I have some question myself. For example, if you send cheers to the player, and do the players see the animation or only the viewers do so?
You could do it both ways.
Okay.
In this sample in particular, like I showed, like the hearts were inside the game. In the case of the CS:GO tournament, only the casters saw it because what you wanted, I mean, you don't want to distract someone during an esports event.
Yeah.
But you wanted to signal to the casters, hey, talk about this dude, look at this.
Okay. Well, and the final...
Or do that. It's not always a dude.
Well, the final question I have, is there any requirement to start the application? Meaning that probably PCs that have low requirements or specification can have problem running it?
Running the SDK? Like locally to
yes.
develop?
No, to develop. No, let's, for example, say that someone wants to be the viewer and they need something specifically or with any type of specification, it's probably...
My cell phone is so far away from me right now, but I have this Samsung A10 cell phone. Okay. It's basically trash. But I was able to play Rival Pick there. I mean, if you can watch like YouTube or Twitch on your device, yes, of course you can consume a mile from there.
Okay, so it has really low requirements. That's good. Okay, yeah, I believe that's everything for now. Yeah, I believe that's all the questions. I think I'm not missing anything. No, that was all then.
Fantastic.
Well, Julian, do you want to follow?
Yeah. All right. Thank you, Alejo. And of course, thanks to Felipe too, who has been giving all these amazing answers. Yeah, if you guys in the chat do not have any further questions, I would like to thank you for being here at DevCom at this very last talk of today's dive-in stage. And of course, I also want to thank Felipe for having this nice talk, which has been going on for quite a while now.
Sorry, you just give me play and I can... Sorry.
All good. No need to say sorry. It's interesting, and yeah, you still seem very happy. It's not like you're exhausted or anything. So that's very interesting too.
I think it's really cool.
That's nice. Yeah, that's really nice. All right. Thanks for joining DevCom, everyone. Thanks for having this amazing talk, and I hope to see you soon. As I said before, for today, this stage is out of service. This is the last talk for today. So let's check one last time. Oh, there actually is one last question.
Fantastic. Go ahead.
Again from Lena. It is. My computer crashed right when you answered my second question. What was it? Let me see. What was the second question? The second one was, can you make games where you... Correct me if I'm wrong, Lena. Please write it in the chat then. But I believe it was, can you make games where you put ads from other people into the environment like this and then gain money if players react to those ads?
And that was the most fun answer. Yes. And like I said, yes. For example, you could have affiliate links for something, for Amazon links. Like when you have these people that paint minis on YouTube and they say, hey, these are the brushes that I use and these are the paints that I use. You could perfectly do that for a game. I don't see why not. It's a business development question. The market is wide open for something like this. I mean, we are over capacity. Let's also take business away from us. Download the SDK and have fun with it. I mean, it's like Lego pieces. I can't actually imagine the things that you can develop with these Lego pieces. So what I can say is that we do the synchronization, we do the events like user input aggregation, so your servers are not destroyed, and we provide you with something that's very easy to set up, so you don't have to be like so technical to get started with something like this that is actually really complicated. From the like, if you try to do it without the SDK, it's really hard. If you try to do something similar, yes.
All right, nice for thanks for answering this question again, for making that clear. So I believe that's been all the questions for today, and I believe that's been the talk then. Thanks for joining us, everyone out there. Thanks for joining DevCom. Thanks for joining Dive in Stage, which once again will end with this talk. And also I would like to thank Felipe one last time for his amazing talk. I don't know, if people have further questions, do you have an email that you want to share?
You can find me on Twitter. I'm going to type it here on the
QA you can chat. Put it in the chat, in the public chat, or in the QA. That's also fine. We can just link it.
I mean, I can do it there. I can do it twice.
Yeah, I see. I'll leave it in the public chat too.
Yeah, and by the way, I'm not like always on Twitter, but in my Twitter profile, there's the link for the Discord server.
Nice.
So then you can like ask me questions there, and of course, and we also have an answer hub, and like all communication channels are open.
That's nice. So remember to look on Twitter, remember to join the Discord, and thanks for being here. We're gonna end for tonight, and yeah, thanks everyone. Bye. $10 seconds is